What we will discuss today. So first of all, where to begin? Second is a little bit about languages and what existing knowledge we can use. I mean, from our existing iOS development experience, we can use to start Android development, or to at least understand the code in pull requests. We will also talk a little bit about developer tools. So what Android developers use on the daily basis. The next part is what is different, which is maybe the most interesting. So what they have that we don't have, and what is like how the main things are solved in Android. And I will show you a little project of mine, which I created, super simple one, just to show you how Android Studio, which is IDE, looks like, from which part it consists, and all the stuff you need to just start developing an Android. So first of all, I will share you this presentation after our meeting. So these three links are the most important. First one is guiding you how to install Android Studio, which is like the only IDE you should use, and I will dive deeper into that a little bit more in a minute. Second one is documentation on language, and the third one is a guide on guide for developing Android applications. So there are some informations, including this book from 2014, which is definitely not cool and totally misleading, because it starts from it asks you to install like a Microsoft IDE and then install extension for developing Android applications. This is totally deprecated way of doing things. And then it goes like learning Java, which is, I believe, not the best way in 2022. So I would definitely not recommend this one. And if you see like there's an old articles like pre-2015 at least, they will probably not cool for you to start on the topic. So first of all, Java was the main language before Kotlin appeared. Kotlin is actually a language which is developed by a third-party company, not the Google itself. So Google started with Java, and there is still a lot of stuff made in Java. But Kotlin is a modern look on the development itself, on the language, on how do we use, how we approach interfaces, OOP, and whatever. So to understand, so I will add a little bit more details in a few next notes. So the important part to understand is that Android or Android applications, they work on Java virtual machine. So JVM by itself is like on a simplest, in a simplest understanding, you can think of it as an emulator, which starts itself in operating system and then allows to run applications inside of it. So every application, every Android application is a process which will run in Java virtual machine. Why is this important? Is that we should understand that every code we will write, no matter what, Java, Kotlin, whatever, it will be compiled in bytecode, and it will run on that Java virtual machine. So if you start to develop applications on Android in 2022, there is no Java knowledge is required. You can use Kotlin like as a first language, and you can like you can develop whole application using almost like or even no Java at all. So this is important thing, and I will explain you why. So Kotlin by itself is like kinda syntactic sugar for Java. So everything which is written in Java will be compiled in a Java bytecode. So resulting code will be the same for Java and Kotlin. This is actually allows a lot of this is like have a number of pros and cons, and one of them is actually allows us to use both languages without any bridges. So like, for example, and we can actually think of switching from Java to Kotlin like we were switching from Objective-C to Swift. So it's like a new generation language which allows us to do a lot of stuff, like modern stuff. To it is type safe. There is like concept of optionals. So it's like modern. It's easier to use. It's usually the code written in Kotlin is usually shorter, but we should understand that the resulting code in the Java bytecode will be the same. It will write the same things like in Java or Kotlin. This actually allows us to have a code converter. So in any time in our application, we can rewrite, or we can actually automatically convert every Java code in Kotlin. It is not the same when you're converting from Kotlin to Java, because Kotlin actually adds a lot of stuff which was missing in Java before. But generally, there is no bridges or something we have, like, for example, when we want to compile the same Objective-C and Swift code in our iOS applications. This is a lot more easier when comparing to Java and Kotlin in Android applications. So Kotlin is fully supported by Google, although it was started like a development tool in a third-party company. Currently, Google fully supports Kotlin. Actually, the company started Kotlin development. They're actually doing IDEs, and Android Studio, which is the main IDE used right now for Android development, also was made by this company. And currently, Google fully approves it. They have like the team which is developing Kotlin. It's like half developers are from this like third-party company, and other half is from Google. Every Google presentations are run on Kotlin, so it's like it is the way to go. Yeah, I already covered this one. So both languages are almost fully interchangeable. You can have application written fully in Kotlin, fully in Java. You can rewrite like easily all those classes. You can convert them using that automatic tool. So yeah, this is like this is how this is much easier than it is on iOS platform, I would say. An important thing, IDE, which is Android Studio, contains Kotlin linter. And it actually allows, so there's like the style, code style, indentation, and everything is already embedded. So when you're converting code from Java to Kotlin, it already uses these linter tool. So rules are already set, which is kind of makes work a little bit easier because everyone follows the same rule. So what I would like to show you is how.
Hey, Alex.
Yeah.
Quick question. Any concerns for performance impact when writing Kotlin and then gets translated into bytecode?
Absolutely no, because it all translates into native Java constructs. Although, like in Kotlin, there are much more modern stuff, but still there's like a feature. So if you're writing Kotlin code and you're writing Java code, you can use Android Studio to see which bytecode will be compiled as a result of compilation of these things. So they're easily like matchable, and you will see that it basically does the same. Kotlin is very, very optimized. It's basically like another syntax tool for a Java. It's still Java under the hood, but so like they're almost the same. Like 99% they're the same.
Okay. Thanks.
Sure, guys. Please ask your questions. So anytime. Yeah. So I want to lead you through this next section, which is comparing how Swift looks versus Kotlin. So on the left, you see a piece of code on the Swift, and on the right, you see a piece of code on the Kotlin. So this exact example is variable and constant. So how we're declaring variable, how we're declaring constant. You can see that the only difference here is that there's a different keyword for constant, which is val instead of let. Yeah, Jim.
Does Kotlin support any kind of precompilers? So maybe you could create a macro for val to map to let or let to map to val. So we could literally copy paste Swift code that,
there is I'm not sure about this approach. So C and C++ files and some few more languages are supported and can be compiled as a resulting application. And there is like a bridge for using C files from Java if you're asking like to import C files. And there is a preprocessor. By preprocessor, I'm not sure it's a preprocessor in the sense we mean like in C and Objective-C. We're actually importing all this stuff. Nothing happens like implicitly, but I'm not sure about that. Never tried to do such things, so probably can't answer that properly.
Because if either that or maybe a script or something could take Swift code and do the mappings into Kotlin.
There are some open source tools which do not work well. I use a tool which is paid. It's like there was a free trial, but the idea is that there's a lot of things which are different on language paradigm level. So it's like it cannot predict. It can actually translate your code, but from the Kotlin standpoint, it would not be a great code. Like it's the same like when we were converting like from Objective-C to Swift. First, from what we started, we actually wrote Objective-C code using Swift syntax, which is not cool. So this is like kind of it. So I will not rely on such tools. But you will see this is like the syntax is probably the best thing. So you will see that it's like with most of the modern languages, syntax is like very cool. So second example is again Swift on the left, Kotlin on the right. You see function declaration and how do we call the function? So we do not have support for how they call it labels, placeholders. And the difference is that return value is so the sign of return value is not like arrow, but just a column. Also, what you can see here is that how do you embed how it's called string interpolation, right? How do you embed values into the string? So it's a little bit different syntax, but still like it looks like very similar to it. Next is class property and function. So you see like class the same, property the same. About a function, there is a syntax which allows to write one-liners using equal. So return type is just inferred from that line of code, and it's like actually skipped. So which allows like to write really short pieces. And there's a lot of things like this in Kotlin. So you can write really short code like. But I will show it a little bit later. Just not overload you.
Looks like it's fun to do things in Kotlin.
Absolutely, and there's actually a big topic why it was called fun. Yeah, and the same like with funky stuff in Swift, I guess. So like another example. So you see how protocol which is called interface, which is abstract interface, how it's declared. The same. The only thing that like return value is like after the semicolon, put after semicolon. Generic function, generics are fully supported, class generics, and yeah, you can see it's very similar to what we see in Swift. So lambda function types, so lambdas or closures or how you call it, they are also the like top level or first level, however they call it, entities. So you can pass it. Their syntax is actually the same as in Swift. I just wanted to show you how they are used in the sense of like we're using it as a returning value. So you can just assign it to a constant and just return it from the method. So this is they're used almost the same. The only difference I would say that we have. So we're not managing the memory, so we don't care about like that self dot pointers and all the stuff. So there is a how it called garbage collector. So it's a little bit easier. We don't care about the how our asynchronous code is working. So yeah, and as you can see, this is like all very similar from what we're already seen in Swift. This is what a little bit different, but still extensions. So if you're doing extension in Swift, you're like creating a separate scope, and you put all those values there. On the right, you see that you can like not use scope at all. You can use like a global space, just declare type, and then just assign some value. So this is a little bit different, but works absolutely the same. So as you can see from these examples at the bottom, how 1 inch is declared and used, 3 feet, it's like it's similar. Collections, like array, there's a situation. So all types are coming, all collection types are coming from Java. So there's a number of types for every particular situation. There is no like directly mapping for array. There is a list, mutable list. There's some more. There's also like no dictionary. There's some more like this. There's hash map and a few different types. They are a little bit different, and we should understand the purpose of each to use of them to be able to use them efficiently. From a syntax standpoint, what you can see on the right is that this is the kind of init method which creates static constant method with a constant number of arguments, parameters, as you wish. And when we're calling the parameter, so it's the same, absolutely the same syntax, like we're just putting the index and saving or receiving the value by index. And the same with dictionaries, which are in general called maps, and there are like few different types of maps, I would say, which are hash maps in general. So almost the same syntax, I would say very, very similar one. I would also recommend you, if you will, if you're planning to dive deeper, to use Playground. There's no Playground in the Android Studio itself, but there is an online Playground which works absolutely the same, and in some way it's even better than Playground in Xcode, because as you probably know, Playground in Xcode is compiled a little bit differently than a real code, and sometimes you see situations which will not appear in the real code, which may like mislead matters a lot, which are just starting development. So this is the different situation. So it's like just a web page. You can go there and you can try everything you want in the code. So we're going to the next section, developer tools. Guys, am I too fast, or is it okay for you? I mean, I'm just like a machine gun, but okay. Okay, cool. So IDE is Android Studio. So there was like a few years ago, as I already mentioned, there was a different option, but it's definitely not supported. It's definitely deprecated. So the only way is this Android Studio. Android Studio is, as I actually said already, it was developed initially by another company, which was which actually developed Kotlin also, but currently it's fully supported by Google, and there's a lot of people from Google working on Android Studio, and like from this company working on Kotlin, and they're all mixing, and so this is the only way to go, and I will show you today how it looks like and how to create a very, very small first project. So the important thing to understand what is Gradle. So Gradle is kind of a build automation tool. It's the mix of it's a number of scripts actually, which will allow you to build your project, to inject your dependencies, to control a lot of stuff. So I will show you how it looks like. On the user level, it's just like a number of files. You put your information in, and when you hit compile, system will just look what is inside of those Gradle scripts, and will build your file according to that everything you put there. So yeah, that is it. For UI, Android developers currently using a tool which is called Layout Editor, which is very similar to Interface Builder, but a lot easier to use. The resulting XML code, and this is an XML. So you can write an XML. You can just drag and drop things the same as you use like in Xcode. This is much simpler when you're combining the complex hierarchies of UI views, and this is the, I would say, still preferred way to use UI, because I consulted with a friend of mine who is the skilled iOS developer. He still says that there is that this option is more popular nowadays. There is a declarative UI framework which is called Jetpack Compose, which works like Swift UI. So what I read about this one is that it's already declared like, the team developing that instrument is saying that it's fully like production ready, but they're still adding stuff, adding more stuff to it. This is probably the main reason why people are not using it for bigger projects. So from my friends who are developing Android like for years, they're still not using it. They still feel like this is not ready, or it cannot guarantee the same fast development as this previous version, which is Layout Editor. So for example, when we will start our Android application, I will stick with this one, because I'm not sure if Jetpack Compose will like just take my time for super simple things. So yeah, I will probably, at least for now, I will probably just stick for the for that layout editor I already showed you. So, and there's an Android emulator, which is pretty the same like iOS simulator. So every code you build and run, you can see how it works. In some ways, it's better than iOS simulator. For example, there is a way to emulate camera, and there's like few more additional things you can do, which you cannot do in iOS simulator. It's not very stable, which is a bad thing about it. From time to time, it glitches. You reload it all the time, but still, we have an instrument to test our applications even without real devices. So these are the most popular Android Studio hotkeys, and I left it for you guys because unfortunately, Android Studio is a cross-platform product, and it's not supporting all standard macOS hotkeys. So like if you're hitting command up, you're not going to appear on the top of the screen, and so unfortunately, it's like yeah, but these are the same. So everything works the same, and I will show you that like in some minutes. So going to the next section, which is probably the most interesting. It's what is different from what we have in the iOS development. So one of the main and the most important concepts is activity. Activity is sometimes equal to an application. And this is the class which may be used like it may contain everything you have in your application. So the main idea, and initially it was the only class which were allowed to combine logic and UI and everything inside one class. It was an activity. So activity itself is like a very separated class. It's very limited in its abilities, but it allows to have all application inside one class using MVC. And it is really possible, and I will show it today, to just inflate, how do they call, when they're taking that XML composed UI and use it into a class, they call it inflation. So you can inflate all your UI into that class reference, all the UI elements inside of activity, and create all the application inside of one activity, if it's a one screen or multiple screens. The initial idea was that activities by itself almost equal applications. So you should be able to request an activity from your application. You can request activity from other application installed on your device and to open it fully like it's a part of your application. So it's like you should be able to like switch. It will look like you're switching between applications, but you are in the sandbox of your application. Activities, there should be at least one activity in the application, but there may be more. This is not a modern way to combine, to compose UI using activity per screen, because there are activity by themselves, they are not lightweight at all. And I will show you, the things we will use for that a little bit later. So there is a thing called intent, which these intents, there are objects which are connecting activities. So for example, you cannot pass an object like a data object or whatever from one activity to another. You cannot set up interaction like delegation or something between two activities. So activity is like a fully how do I say it? It's like an application limited by sandbox and is represented by an activity. So usually for modern applications, there is one activity, a number of different entities, which are called fragments, and I'll touch it a little bit later. So although we have activities, an activity can serve as an app delegate. This is not actually an app delegate, and it is of course not in Singleton. There is a class which is called main application, which is not included in the project by default. You can include it. So usually you store all your stuff which is related to global events like push notifications or something in activity. Or if you don't want it, you can use this main application class, which is a standard way. It's kind of like an app delegate. So there is also ability to extract some code to a main application class, which is one per app lifecycle. So this is the very important entity, which is called fragment. Fragment, you can think of fragment they're kind of like a container view controllers themselves, or views. Activity by itself has its own life cycle. There's a number of methods which are hit on activity creation. When activity, I just forgot how it's called. So like we have view did load, view will appear, view did appear. There's the same amount of for an activity. The fragment always relies on activity. It cannot be used itself, but activities are managing fragments. So fragment can contain its own UI, and fragment class by itself contains logic in an MVC manner. So you can embed a number of fragments in one activity and call it an application, and then just set up how do fragments interact with each other, and like how do we navigate from one fragment to another fragment, and that's how it works. So important thing to understand is that there is a life cycle, and life cycle is a little bit more complicated, I would say. So for activity, so what you see on that left part of the image is activity life cycle, and fragment, which is put at top of that life activity, will rely on its life cycle. So for a number of methods which activity will hit when it will change its state, a number of fragment adds its number of methods. This is probably the biggest downside of using the fragments, but still they are super lightweight and is preferred way to combine UI and some logic. So here I just wanted to show that fragments can be used in a lot of different ways. You can show a lot of fragments at the same time. You can use stacks. There are patterns which allow us to imitate, or I would say not implement. I would say imitate, like tab bar or navigation bar. So this is how fragments used with activities. So another important class, and in general, there is a thing which is called context. Every activity is inherited from context, and context is like a global class which allows you to have access for all assets added to the project. Everything which is related to UI relies on context. A lot of methods which are modifying UI in some way require context. So every activity creates with an instance of context. And then this context will be available from every fragment, which will be the part which will be added to that activity. So there, it takes some time to handle it because, for example, it may not be ready on the activity initialization. So the context appears a little bit after it. And there is like, there may be an interesting situation when you are using different contexts, and sometime you can pass wrong instance of context, like which should be used from one activity to another one. This is, I would not dive deeper on that, I would say, at least for now. But the context is the thing which is which you cannot avoid. So in every project with every activity, you will have context, and you will use it. You will use it a lot. So what is also different is that there is a link on the material guide. So this is the official Google guide on how should you do your UI. This is a very big one, and this exact chapter, which is called components, is dedicated specifically to how material is used in Google in Android applications. It is not like very strict one, so you can use like your own elements, you can modify them. This is just a recommendation, but there is some elements which are described in this guide. Their work a little bit different. For example, system implementation of what we call tab bar, which is called bottom navigation, works really differently. So if you want to mimic the behavior of tab bar, you should create your own. And from what I've seen working in my previous company, the top products from the top vendors, they're actually doing one design which is actually iOS design, I would say, and that design then is copied into Android platform. So like, for example, if you will check Android Facebook application or Instagram application, they look almost similar or even the same as iOS application. So I believe this was started because at the very beginning there was a patent wars. Apple put a lot of patents on the very simple and basic like interactions, tab bar, nav bar, and all that stuff. But currently, from what I see, a lot of iOS stuff is also a lot of stuff which is used in iOS, used also in iOS, used also in Android development, or mimics the same components. So I created a small project for you, and I will show you it in a minute. This is the link, so you can download it. If you will install Android Studio, and there's also so you can open it and check it. There's also one thing I forgot, and I would say it right now. So Android Studio is unfortunately not that easy. It's easy to install, but it's not that easy to compile your first application. So usually Java is missing, JDK, which is Java Development Kit, some other components. So the best way I found, because there's like different versions of Android Studio for different processors, like Intel M1, there's different for different operating system version, even on Mac. So there's a number of it. The guide should lead you to a one you need, but after you installing it and opening a project, you can actually open the project, but you can compile it on the Android emulator. What I found is that you are downloading this simple project, you're opening it, and then you will see a lot of errors like this thing is missing, this thing is missing, and you just press download, 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 and it will set everything up for you. The only thing you will need after that is to add an Android emulator, because Android emulator is not added by default. So in Xcode, like just running, like compile and run, hitting the button, and it will open in the simulator. Simulator is not installed by default, so you should create at least one, and then you will be able to see your application in the emulator. So yeah, this is the link, and I will share this presentation with you guys, so you will be able to check it. Yeah, so this is where the presentation ends. So now I will show you how the project looks like. This is a very, very small application. You can see Finder folder, right now on a black screen. Okay, cool. Okay, so there's an application, number of files and folders. The only one we are interested in right now is build.gradle, which is kind of XC workspace or XC, how it's called, that Xcode file by default. So double clicking by it, you are opening that project in the IDE. So there's a absolute minimum amount of files. I just wanted to not overload you guys because there's a lot of information like for one meeting, but still. So what you will see here will probably be at least a little similar for what you see in Xcode. On the left, you will see that navigator pane. So you can like navigate to project. You also, there's like number of folders. Main screen is like you see your file. There's like tabs, so you can switch between files. There's a run button. There is a debug, which is a different button from this one. So from what I would start is the project. I'm not sure. This is probably too small for you, right? Do you see that folders, their names? Because I'm on a big screen, so I will share it on a smaller screen. So, what do you think?
It says Java.
Okay.
As manifest. Yeah. A little small, but I could still see it.
Okay. So project structure. So when you're first time opening any project in Android Studio, so what you see here is like two folders. First one is app, so all app files contained there. And you see Gradle scripts. There's a number of text files which are Gradle scripts. I will open just one, for example, to show you what's in there. So there's like basic configuration. So this is basically like info.plist. So how your project should be set up with which like option settings, whatever. So there's like compile my project with this SDK version. SDK version maps, and this one is maps to the operating system version. So developers say 30, 31, 32, and users say like Android 6, Android 7, whatever. So there's like version code, version name, which is the minimum operating system version we support in our application. There's like, I would not dive deeper in this one. And you have the section which is dependencies. So these are dependencies set by default. So you just list them there. They're automatically downloaded. These are the system ones, which are required for application to work on a basic level. So what you see, so that yellow thing says that new version is already available. So it's checks for versions automatically. It can download from GitHub, from whatever. You just put a link there, and it will download it. And when you will hit compile, it will just create your application with all those dependencies compiled. So this is the only one I wanted to show you. So going inside of app, so there's the thing which is manifest. So as you can see, this is the XML file, and actually XML used a lot in Android development. This is the preferred style, which is run by default. I'm not even sure if we can use the different ones for files, for setup files. So this is actually kind of I'm not sure that there's an analogy for that. Maybe kind of like info-plist. So there is like a tag application which declares like a very basic things like how application, which name should be shown, like application name. So if there is if we want to round our icon and which one, like which theme we will use for our UI and whatever. The only important thing I would say here right now is that we're declaring all activities which are in our which we will use in our application that should be declared here. Otherwise, they're not visible inside of application nor outside of application. So other applications will not be able to call them and use them in their applications. So it's very simple for now. It's usually become a much bigger file. There's a lot of different setup, but this is enough for starting our first application. Inside of Java folder, there's one more for generated files, but we will not even cover that today. It's like auto-generated files, which are required for compiling applications. There are 3 folders, which are folder with our code, Android test, and test. So these two, it's like different targets, same as in our Xcode applications. So all our application files, they are stored inside of, almost all of them, they're stored here. There's only 2 files, and I will show you them in a minute. So one is the main activity, and I will explain it how I'm what approach I'm using for UI here. What I also would like to cover, that there is a folder which is called res, which is predefined, and in all Android applications, it's set by default. So there are some subfolders added by default. Like for example, drawable, it's the things we will use as asset files. I would say I would match it to asset. How it's called, like where we keep our assets, right? So layouts are XML files like this one, which are used for layout editor, which describe our UI. So basically what you can see right now is an analogy of XIB file in Xcode. The great thing about that is that the only thing required by system to use that file is that header. So it creates some references to system like resources. And then this is all you need to combine your UI. So like there is a text view, you see, so on the left, I'm selecting it and it shows up here, it highlights a little. There's like, this is ID, which I will use in code, basically like IB outlet. Width constraint, height constraint, there's a basic text because this is the text view, just like a UI label or something. And few constraints. So the constraint to the top, start to start, it is actually leading, and this one's actually trailing, and that's it. There's no like additional XML. There's no like additional stuff. There's no that storyboard hell, which is which allows us like for thousand lines. This is actually how UI looks like, and some developers are actually prefer to write UI like in this style. They're just opening this window, so like just the code. There's 3 modes. So in this one you can drag and drop. In this one you can use both, and this one you can just like open the file and just write these things. Just insert them like you're inserting like tags in subtags, and that's how it works. It's super easy. So yeah, and there's few more. I would not touch this one, but I would touch this one. So values of folder. As you can see, these are the colors which are already added by default. So all the values, they're stored here like this. ID by itself shows the value, like if it's a color, it shows the color itself. If there is a string, so this is actually like localized strings and whatever. So it's all stored like this, localized string, all assets, all resources stored in XML files and easily available in classes. So now I'm going to class itself. So the only class which is actually contains at least like some MVC logic, I would say, is this one. So you see the whole class there. It's actually pretty, it should be pretty similar for you. So what you see here is that this is the main activity class. So this one is the class from which it inherits, it's the system class. And this one is how do we assign to delegate. They're not called delegate, but they serve the same. So you can have communication from one class to another, for example. And let me compile and show you what exactly this application does. That actually shows a small, what is called table view in Xcode, and it's called recycler view here. And just few values from static list, which is array, which is actually kind of an array. So yeah, I'm compiling right now, and it should be done in seconds. So we compile right now. So what you see here, these two are placeholders for like IB outlets. There's no like way to set up IB outlets, but Latent is kind of lazy initializer. So it allows us to not give initial value. And there is a method which is called an initializer, which will set up all this. Oh, yeah. Let me try to make it a little bigger. Not sure. Yeah. So this is the application, just the header and just the recycler view, which is analog of table view, and it just bounces a little bit and reacts. So the image reacts when we are tapping it. So how is all this working? So these are actually absolute analogs of IB outlets. This is the private constant list of some values, some just like literal strings. This onCreate methods is a direct analog of viewDidLoad. So what you can see here is that there is a system saved instance state, which will allow on some situations like when our application is appearing or disappearing from screen, or user goes to another application, like basically that background for ground actions. Then we're using the R is the interesting thing. So R is the global point of access to our assets. Like you can write R, then you can write string, and you can use one of the strings which was listed in that XML file. The same with colors, localized strings, and whatever. So then we have method. We are calling the method instantiate UI components, which is actually assigning. So this is like find view by ID. It goes to that XML files, extracts the view with its by its ID, and assigns it into that variables or constants or whatever. There is also a method which is called setup adapter. So adapter is the preferred way to deal with recycler views. So it's like UI table data source and UI table view delegate. And there is setup UI method, which does only the one thing. So it's basically takes this, it basically sets the text to that top text view, which we are using as header or whatever. So this inside of this method setup adapter, we have like already data recycler view, which is analog of table view. And we set its adapter to this exact class. So inside of that class, we are describing how do we want our data to be shown. And this is the basic setup, which allows us to have UI table view behavior. So there is no separate elements for UI table view and UI collection view. Both are done by recycler view. If you want vertical layout, horizontal layout, or multiple rows and columns, we just creating it with like some predefined or created by our own versions of this layout manager, which allows us to change how data will look like. And the very last thing is data adapter class itself. So this is kind of syntax for initializer. So when we are initializing the object, This is the short version. So this we should pass these to parameters, which is objects, our data source, and there can be used right from there. There is no need to declare additional properties. So this interface here is a protocol method used for delegation. So inside of there, we will set up our items, which is analog for cells, and we will tap on them. We will be able to see that in our event log, or how's it called? Yeah, so by tapping on these, we should be able to see. Let me check already. Yeah, not sure, but some I need to look at it. Should be there if I haven't deleted it. Yeah, so this is kind of like a console, but works a little bit different. I would not dive deeper inside of it right now because there's like a lot of options you can see there. So yeah, it's there. It's in run. So by tapping on this one, I'm adding values there. So yeah, so this get item count, it's number of rows, or how it's called. These two methods are kind of cell for row at index, which are create our item, which is kind of cell, set it with data, and responsible for how it will look like to the user. And this is actually private class embedded inside of this one. This is actual class which is responsible for item itself. So we have two IB outlets, I would say here, which are actually so you can see that they're inflated here and saved assigned to these properties. And there is a bind method which puts set and click listener, which is the same as gesture recognizer. So our listener is our class, and if we will go to our class, there is a method, a reading method of that class, which is actually allows us to do some functionality inside of the class. So basically, delegate. What it does right now is just prints some stuff into the console.